I'm Hudson Groover for Physics 2212, Lab 2, Charge Tape Revisited. In this lab, we revisited Lab 1, but this time we developed an improved model in GlowScript to demonstrate, visualize, and help calculate values of a charge evenly distributed across the tape. So in this, the system again is tape B, and the surroundings is tape A. And we found that the point charge is 2.47 e to the negative 9th coulombs. So in this, we make a few assumptions. We ignore air resistance on a moving object. We charge evenly distributed across a line charge, so more two-dimensional than 3D. And we assume that each U-tape made has about the same amount of charge evenly distributed along the length of the tape. So concepts and measurements for calculations, we use a lot of the same measurements. Well, we do use the same measurement. Length of tape was 10 centimeters and everything. But this time, which we can see in the code, we look at we make a summation of all the charges, like we divide the tape into multiple different charges, and we compare each charge to each charge from B and A. So now they are made up of a line of charges instead of just one. And this complicates the math, but that's why we use for loops and why coding is very helpful. So we create a net electric force vector and a net electric field, and we go through the for loop and we iterate and add to this as we go to make an overall force vector. And so then when you simulate this, it shows this. So basically the for loop is adding up all those individual green arrows on all the different particles, and that's what the white arrow is, and the yellow arrow is gravity, and they almost equal each other because the math is a little bit with little numbers, it gets a little inaccurate, but it's very close. And so errors is ignored air resistance, treated tape as a line of point particles when it's actually three-dimensional, and the tape lost charge during procedure, like through the air, handling humidity, changes all that. And the measurements were difficult to the equipment. So everything that lab 1 struggled with, this lab also struggled with, but the improved model is much more accurate. And so what if you had modeled each of your tapes as a single point charge, like in the previous lab? Well, in the previous lab, we had 4.38269 e to the 9th coulombs. But in this one, we had 2.47 e to the negative 9 coulombs because there was more points interacting with each other. So it should be more accurate because it's close to reality. And that's why they differ, because we're looking at tape is not a single point. It is a three-dimensional thing, and point particle is only 1D. But when you add the line, that's 2D, so we're one step closer to reality. So that's why it should be more accurate.